At this point, I will take some time explaining basic methods for manipulating datasets. That can take various forms, such as substituting data values within datasets, or ordering, aggregating, or taking subsets of datasets. For this video, we will open the script file 06, substituting, reordering, aggregating, and subsetting data.r within RStudio. As context for a possible reason for substituting data values, an analyst will often need to deal with what is known as dirty data. Data might be dirty for a variety of reasons, such as being improperly formatted, having missing or incorrect values, or perhaps using inconsistent abbreviations for a given term. In the sample code shown in the source pane, I have used the command unique to identify the state names appearing in the electricity rates dataset. This reveals that, in addition to the use of standard two-letter abbreviations for states, for example, FL for Florida or WY for Wyoming, there are instances in which the names of West Virginia and Texas are fully spelled out. This is an example of dirty data. The sub command, which stands for substitute, is used to rectify this in the sample script. In this example, sub has three arguments: West Virginia, spelled out, the abbreviation WV, and the state field from the electricity rates dataset. What is happening here is that R is looking in the state column of the electricity rates data and replacing any occurrences of West Virginia with its abbreviation WV. On the same line of the script, you see that the output from the subcommand is then being assigned to the state field of the electricity rates dataset. Essentially, R is grabbing the state data from the dataset, fixing that data using the subcommand, and then using that corrected state data to overwrite the original state data in the dataset. Sometimes you'll want to display your data ordered by a particular column. In the sample script, I provided an example that displays the empty cars data, starting with the highest horsepower car at the top and then continuing in order of decreasing horsepower. If you look at the right side, you will see that it lists the object, empty cars, followed by arguments contained in square brackets. From a previous video, you may remember, or at least I hope you remember, that this is a standard format for specifying elements within a data object, in this case the empty cars data object. First, you list the row or rows of interest, followed by the column. In this case, the row number is represented by a command using the order command. The order command contains two arguments: the data to be ordered, in this case the horsepower data from empty cars, and the order in which the data is to be ordered, from largest to smallest. If true were to be changed to false, the order would be reversed from smallest to largest. So, for the rows of interest, we are asking for all rows listed in order of descending horsepower. For the column number, we have left it blank, meaning that we want all of the columns. Therefore, we list all rows in order of descending horsepower and all columns. We then assign that to a new object, which we name order by horsepower. You may sometimes wish to aggregate your data based upon grouping it into categories. R is especially literal in this case, given that the command used to aggregate data is aggregate. In the example in the source pane, the aggregate command has four arguments: the name of the data object that is being aggregated, empty cars; by, which indicates the data fields to be used to group the data; fun, which is the function to apply to groups of data. Here we are taking mean values of groups of data; and na.rm, which indicates if you want to exclude data for which no value has been provided. In this case, we do. The by argument can itself have multiple arguments. In this example, we wish to first group the data by the cylinders field in empty cars, and then by the gears field. In the output of the aggregate command, we are naming these cylinders and gears, respectively. In this example, we opted to calculate mean values. For other options, I recommend you refer to the math section of Project R's R reference card, the URL for which is provided here. At times, you will only want to work with part of your data, that is, you want a subset of it. Naturally, the command for doing this is called subset. In the example shown here, subset has two arguments. The object from which you are taking a subset, in this case empty cars, a specifier indicating which data records you want. For our example, we are interested in records for which the number of cylinders is 6. For the second argument, it is important to note the use of two equal signs rather than a single equal sign. If you wrote sil equals 6, you are assigning a value of 6 to sil, which is not what you want to do in this situation. By writing sil equals 6, you are asking a question. For this record, does sil equal 6? If it does, you will include the data record in your subset. Once again, I'm offering a few quick exercises that you may complete at your discretion. Number 1. Modify the earlier command to put empty cars in increasing order of engine displacement, disp. Modify the earlier command to aggregate empty cars by carb and sil. Number 3. Take a subset of empty cars for drat greater than 4. Now that you are getting a better sense of how to handle and manipulate your data, our next video will explain how to export data from R.